The normal conviction among most scientists is the hypothesis of ancient infinite explosion, which states the principal explanation for the beginning stages of the universe. This speculation wraps the development of stars, planets, and all life on those planets, including ourselves. Notwithstanding its to some degree eccentric name, the huge explosion offers an obvious investigate what might have occurred. From the beginning, the universe was combined into a short space more unassuming than a pinhead, with particles thickly squeezed. From this minuscule point, a tremendous impact of issue and energy occurred, known as the huge explosion. This occasion, happening billions of years prior, clears a path for the spreading out of huge history. Nonetheless, changes in logical information have prompted expanding irregularities with the forecasts of the hypothesis of ancient enormous explosion. At the point when NASA sent off the James Webb Space Telescope, the biggest and most developed space science observatory at any point constructed, analysts conjectured that its perceptions would uphold the hypothesis. Tragically, after only 1 year in space, the telescope dumbfounded researchers with its outstanding ability to peer profound into the universe's past. The James Webb Telescope's heavenly capacities have revealed cosmic systems following back to a period so old that it challenges how we might interpret the universe's starting points. This revelation has touched off an extraordinary examination concerning what existed before the huge explosion. One fundamental second in this excursion happened when cosmologist Rohan Naidu, working with information from the telescope, coincidentally found a world going back just a short time frame after the huge explosion, making it the most seasoned universe at any point noticed. Naidu's disclosure sent shockwaves through standard researchers, featuring the unprecedented capability of the James Webb Telescope. Its central goal to reshape how we might interpret the universe has recently started, promising to divulge remarkable bits of knowledge into the earliest accounts of the universe's presence. This epoch, scarcely explored previously, holds the way to figuring out the arrangement of the primary stars and systems. The telescope's disclosures have toppled beginning presumptions, uncovering systems with qualities surpassing past forecasts. This unexpected flood of early worlds has lighted a hurricane of logical request, inciting experts to accommodate these perceptions with existing speculations. As analysts grapple with these disclosures, they go up against huge inquiries concerning the basic idea of the universe and the powers molding its advancement. Furthermore, the James Webb Telescope's innovation is progressive. Situated 1.5 million kilometers away from Earth, safeguarded from earthbound obstruction, and cooled close to outright zero by its tennis court-sized covering, the telescope conveys a huge section reflect and incredibly fragile instruments intended to reveal subtleties of vast sunrise. As of not long ago, this unbelievable occasion, known as enormous sunrise, happened approximately a few 100 million years after the huge explosion, denoting the period when the main stars and systems started to shape. The course of how this unfurled stays a subject of extraordinary review, with speculations going from the impacts of dull matter and dim energy to the communications among starlight, gas, and residue. The telescope's perceptions of worlds from infinite first light proposition a special chance for cosmologists to test how they might interpret these secret peculiarities. By analyzing these antiquated systems, scientists can either affirm the legitimacy of their ongoing models or uncover holes in understanding that could prompt huge new disclosures. At first, it was projected that the telescope would find a couple of weak and little worlds in its pilot studies. Nonetheless, the truth has far outperformed these assumptions. The telescope's absolute first photos of the far-off universe revealed various worlds with ages, sizes, and brilliance that surpassed all gauges. This astonishing wealth of early universes has set off a race among stargazers to guarantee new records for the earliest known worlds. Every day creates reports of one more record-breaking disclosure, leaving laid-out researchers in wonderment and provoking a reassessment of how we figure out vast history. Following the James Webb Telescope's disclosures, researchers and onlookers have hurried to figure out the presence of these suddenly adult early cosmic systems. Some conjecture that defects in the examination of the telescope's underlying perceptions may be answerable for these peculiar discoveries. By The agreement states that these disclosures address a change in outlook by the way we decipher the early universe and proposition enticing clues about the idea of enormous development. The new exposures from the James Webb Space Telescope with respect to early worlds bring up critical issues about the idea of the universe and challenge the suppositions of standard cosmological models. While certain scientists estimate whether these perceptions can be accommodated with existing hypotheses, others propose that they might be the main signs that the universe is substantially more perplexing and unconventional than recently imagined. Being referred to isn't anything not exactly our basic comprehension of how the precise universe we know emerged from early-stage bedlam. The early revelations of JWST can possibly reshape how we might interpret grandiose history, revealing insight into far-off cosmic systems and distant universes, as well as on the actual presence of our own smooth-way universe. As Imprint McCarran, senior expert for science and investigation at the European Space Office, suitably puts it, you construct these machines not to affirm the perspective yet to break it. You don't have the foggiest idea how it will break. The starting points of JWST can be followed back to the Space Telescope Science establishment in 1985, even before the Hubble Space Telescope was sent off. Around then, G. Winger, then at that point appointee head of STSCI, was entrusted with imagining what could come after Hubble. In spite of starting reservations, Winger and a little group started laying the preparation for what might eventually turn into the state-of-the-art space telescope, later renamed JWST after a previous NASA head. Dissimilar to Hubble, which principally notices apparent light, JWST was intended to find in the infrared range, permitting it to peer a lot further into the universe. This capacity is vital for concentrating on early worlds whose light has been extended into the infrared because of the extension of the universe, making them imperceptible to telescopes like Hubble. With its enormous and cold star-like mirror, JWST turned into the best device for opening the secrets of astronomical daybreak. The need for JWST was highlighted in 1995 when the Hubble Profound Field Perception uncovered a plenty of universes in what was believed to be an unfilled fix of sky. This disclosure indicated the extravagance of the early universe and laid out the significance of a telescope equipped for digging a lot further into infinite history. After more than 20 years of improvement and at an expense of around $10 billion, JWST was at last sent off on Christmas Day in 2021. By July 2022, starting its most memorable year of logical observations was prepared. Early undertakings, similar to the Grandiose Development Early Delivery Science Review and the GRISM Focal Point Enhanced Overview from Space, were explicitly intended to look for early systems. While starting assumptions were humble, the outcomes far surpassed assumptions. The JWST perceptions have tested existing thoughts regarding the early universe, uncovering cosmic systems that challenge customary models. These frightening disclosures feature the significance of pushing the limits of logical request and highlight the extraordinary capability of state-of-the-art advances like the James Webb Space Telescope. As analysts keep on unwinding the secrets of the universe, they are ready to reshape how we might interpret vast history and the powers that have molded our universe into what we see today. The early perceptions made by the James Webb Space Telescope have bewildered space specialists by uncovering extremely far-off worlds. Before JWST, the most far-off realized world was GN-Z11, found in 2015, with a redshift of 11, relating to a grandiose season of around 400 million years. Notwithstanding, from the beginning of JWST perceptions, the Glass Group, drove by Rohan Naidu and another free gathering made a striking revelation. They distinguished a universe named Glass Z13 at a redshift of 13, about 70 million years sooner in grandiose history than GN Z11. The fast speed of these disclosures was worked with by further developed techniques for surveying redshift, which, while less exact than direct estimations, give a speedy gauge of a system's distance. Surprisingly, Glass Z13 showed up incredibly splendid and enormous, previously containing a heavenly mass tantamount to billions of suns, regardless of being essentially more youthful than the smooth way. Resulting perceptions revealed much additional shocking revelations. Numerous system up-and-comers with assessed redshifts as high as 20 Eros, demonstrating their reality just a short time frame after the huge explosion. A portion of these systems showed structures not expected to show up, so right off the bat, an enormous history. Moreover, proof emerged for worlds comparable in size to the Smooth Way at a redshift of 10, under 500 million years after the enormous detonation. These fast advancements challenge the assumptions for the standard cosmological model, lambda cold dull matter, which portrays the universe's development in view of how we might interpret dim energy and dim matter. As per this model, worlds of such size and iridescence shouldn't have framed so right off the bat in vast history. The development of monstrous systems in the early universe presents a basic riddle for cosmologists to tackle. To comprehend this problem, it is essential to get a handle on the beginning phases of the universe's development in the main minutes after the huge explosion, when the universe was a warm and thick soup.